In today's lesson, we are going to be looking at what is called the discriminant. So this is kind of a continuation of the quadratic formula, mostly because it just contains or it focuses on a specific piece of the quadratic formula. The main goal of this lesson is to determine how many real roots a quadratic equation has without actually figuring out what they are. Right? So in some cases when we're modeling it or we look at a quadratic model, we may just want to understand what does it look like. Do we have any roots? Do we have any points where it crosses the x-intercept? And we're going to go through the different types of quadratic models that we may get or the different forms and see how we can do that. Some of them are a little bit common sense based on what the equation tells us, but in some we may need to learn about the discriminant. So recall that the zeros of a quadratic function refer to its x-intercepts. On the graph. So we talked about, or we did a warm up in the previous lesson where we saw that we could have different scenarios. We could have two zeros or two x-intercepts. So maybe our parabola looks like that, or it looks something like that. It could have one x-intercept where the vertex is directly on the axis, or maybe it's something like that. And then zero x-intercepts. Possible scenarios look something like that, right, where it doesn't cross the x-axis. So again, those are the three scenarios that we could come across. Now, zeros are the x values that solve a quadratic equation. So if we had a quadratic equation, ax squared plus bx plus c, if we set it equal to 0, that would, and we wanted to solve, the values of x would be our zeros. And the method used to determine the zeros of a quadratic depends on the form of the equation. So like I said, we're going to look at the different forms. A couple of them may be common sense, and then some of them we may actually have to use something new. So if we're looking at the factored form, so in this case for our factored form, remember factored form is y equals ax minus r times x minus s. Again, hopefully you remember that these two values, the r and the s, these represent our x-intercepts. Again, remembering that we take the opposite of the value in them. So if I look at the first one, y equals 3 times x minus 4 times x plus 2. In this case, x minus 4 means that I have one x-intercept that is positive 4 and one that is negative 2. I have two different x-intercepts then, so there are two zeros. For the second one, negative 2x and x minus 5. In this case, if I look at in the second bracket, for sure I can see that one x-intercept is going to be 5. In the first one, there's nothing with the x, but what would I subtract from x? Well, in this case, I would be subtracting 0. That's why we don't see anything there. So I have an x-intercept at 0 and 1 at 5. So again, I have two zeros. If I look at the third one, y equals 2 times x plus 4 squared, this would just could be written another way as 2 times x plus 4 times x plus 4. Right? Or you might say, well, that's vertex form. Either way, we can see that we have the same x-intercepts, so this produces the same x values or solutions. So negative 4 and negative 4. It's the same thing, which means essentially that I have 1, 0. So that's how we can tell from looking at the factored form how many zeros it has. Again, the goal isn't really to determine what the actual x-intercepts are, just how many of them there are. If we look at vertex form, it's a little bit different because the vertex form doesn't tell us what the x-intercepts are, but we can use some kind of general reasoning based around what the vertex form does give us. In this case, we want to find the vertex, which is just the h and the k value. The vertex, again, is just the h and the k value. And we want to know the direction of the opening. So this comes from our a value. Right? If it's positive, it opens up. If it's negative, it opens down. And from there, we can kind of picture what it's going to look like and then determine from there, are we going to have 1, 2, or 0 solutions or zeros or x-intercepts. So if I look at the first one, y equals 2 times x minus 4 squared minus 3. So in this case, my vertex is 4, negative 3, and the a value is 2. So this tells me that the vertex is above, not above, below, looking at the wrong coordinates, below the x-axis. And that's because of this value here. Right? The y value is negative 3, so it's below the x-axis. The a value tells us that the parabola opens up. So therefore, I'm going to have 2 zeros. And you might say, well, how do you know you're going to have 2 zeros? Well, if I were to just roughly sketch this, again, not really concerned about where it is. I could actually look at the plot. So 4, negative 3, so it's down here, and it opens up, meaning it's going to cross the x-axis at 2 points. Again, I'm not concerned about where those 2 points are. I'm just concerned about how many times does it cross, or how many x-intercepts there are. For the second one, y equals negative 2 x minus 4 squared minus 3. Very similar. The vertex is still 4, negative 3. But now the a value is negative 2. So in this case, the vertex is still below the x-axis because, again, of this negative 3 means it's below the x-axis. But now the parabola opens down because of that negative a value. So if we try to picture what that's going to look like, we just draw a rough sketch. We know the vertex is the same spot as before, but now it's opening down. Is that parabola ever going to touch the x-axis? Nope. Not if it opens down. So that means I have 0 zeros, or 0 x-intercepts. If we look at the next one, the vertex is 4. And because I don't have a k value, the vertex is going to be 0. Or the k value is going to be 0. I don't see anything added or subtracted here, right? So you could say it's minus 0 or plus 0. That's the only number that you can add or subtract, and it doesn't have to show up. The a value is back to being 2 or being positive. Now, because the k value is 0, that means that the y value has not changed. It hasn't gone up or down. So this means that the vertex is on the x-axis. It's on the x-axis and the parabola opens up. Realistically, it doesn't really matter whether it opens up or down in this scenario. Because it's on the x-axis, there's only going to be 1 0. So if I try to picture it, I have my vertex on the x-axis, and with the parabola opening up, the only time it's ever going to touch the x-axis is at that vertex, or at that single point. So there's only going to be 1 0 or 1 x-intercept. So you could use some general reasoning to then figure out what the zeros, how many zeros you have are. You could figure out this information by looking at the vertex in the direction of the opening, and then drawing a quick sketch if you need to, if it helps or it's easier to visualize. But again, once we know the vertex in the direction of the opening, we should be able to figure out how many zeros we have. So again, relatively straightforward. In the third form, in standard form, what we can do is we can go through and we can determine the number of zeros. We can use the quadratic formula, which we looked at in the previous lesson. Or we can open up a graphing calculator and try to sketch the parabola based on the equation. Now, Again, we may not always have a graphing calculator available, so let's look at the quadratic. Spelled it wrong. Let's look at the quadratic formula, because we can go through, plug our information in and solve, and see what answers we get. So if we take a look at the first one, 4x squared minus 2x minus 3 equals 0. Again, we have our a, our b, and our c value. So we can plug that into our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So negative 2 plus or minus the square root of negative 2 squared minus 4 times negative 3, all divided by 2 times 4. So a little bit confusing with the negatives, but again, all you're doing is substituting values in, and now you're going to go through and calculate. So negative 2 becomes positive 2, right? A double negative just becomes positive. So 2 plus or minus, we have negative 2 squared, which is 4, minus, which work out to negative 48, all divided by 8. So this then becomes 2 plus or minus the square root of 52, all divided by 8. Again, like we said, from here, this is where we would split it off into our two parts. 2 plus the square root of 52 divided by 8. And 2 minus the square root of 52. Divided by 8. We'd get our two answers, which in this case would be negative 0.65 and 1.1. So from here, we can see that we have two different x-intercepts. So in this case, we would have two zeros, or two x-intercepts. We can go through the next example. In these cases, I'm just going to go through and just at least get you started by filling in the information. Then I would recommend you trying to go through and just going through the calculation on your own, just so that, again, you get more familiar or more comfortable with using the quadratic equation. So negative 12 plus or minus. I'm not going to rewrite the equation because we can see it up here. So I'm going to go directly into plugging in the information. So negative 12 squared minus 4 times 5 times 9, all divided by 2 times 5. So again, I recommend you pause the video, try to go through and solve this on your own and determine what the zeros are. So if you go through and do the calculations and then split it off into your two parts, you should get an error in both cases. And that's fine, because when you go through and you solve, right, under the square root, you should get a negative value, negative 36. And can you take the square root of a negative? The answer should be no, or the answer is no, because you can't square root a negative number. There's no two numbers that when you multiply, they become a negative, right? A negative times a negative is a positive times a positive is a positive. In no case do you have a negative times a positive, because those would be two different numbers. Now, you might talk about imaginary numbers. You might hear about imaginary numbers. Again, that's something a little bit more complex. We're not going to worry about that. So if you get a negative value and you try to square root it, you'll find that it won't work, which makes sense, as we just mentioned. So that's why you have the error in both situations. So this means, well, did you do something wrong? Nope. What this means is that because we found an error, this means that therefore there are no x-intercepts. So that's perfectly fine if you get an error in both scenarios. You would have no x-intercept, so this would be one of the scenarios where it's either above the x-axis and opening up or below the x-axis and opening down. It's perfectly okay. In the final example, again, same idea, a, b, and our c value. So again, I'm going to start you off by just at least plugging in the information. So negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 1, all divided by 2 times 1. So again, I recommend that you go through, do the calculations on your own, determine what your two x-intercepts are or your two zeros based off of this equation. And we'll come back and we'll discuss the answer. So when you go through and you go and calculate, what you should find is that in both cases you get a square root of 0, which is 0. So if you add or subtract 0 when you break it off into the two parts, you should find that you get the same value. 2 plus 0 is 2, divided by 2 is 1. 2 minus 0 is 2, divided by 2 is 1. So in this case, we get the same value when we split it off. This doesn't mean that we have two x-intercepts. This means we just have one because we have the same value. So therefore, we have one x-intercept, or 1, 0. So that's how we can find the different x-intercepts, or the number of x-intercepts when dealing with the standard form of a quadratic equation. Now, while we get the answer, we get the number of x-intercepts, the goal was to really find the number of x-intercepts without having to go through the whole trouble of determining what they actually are. Right? Because the quadratic formula, although it's just calculations, it may not be the easiest formula to use, right? Depending on what the values are. Right? And again, that's not what we're looking for. We're just looking for how many x-intercepts does it have. And there is a piece of the quadratic formula that specifically tells us that. So if you go back and take a look at the three different examples we just did, was there something that determined what our x, or how many x-intercepts we had? Think about when we split off into the two parts, was there something unique about the three different examples that we had that kind of helped identify the number of x-intercepts? And if you found it, great. If not, that's okay. But what it is, there is a specific part, and it's called the discriminant. And the discriminant is the specific part that's underneath the square root. So the b squared minus the 4ac. So that specific part is called the discriminant. And that part specifically tells us what the x, or how many x-intercepts we have. So if I look back at the first example, I look at my a, b, and c value. If I look at just the discriminant, so the b squared minus 4ac. So negative 2 squared minus 4 times negative 3. This gave me an answer of 52. And I had two roots, or two x-intercepts. In the second example, again looking at the a, b, and c, so negative 12 squared minus 4 times 5 times 9. This gave me negative 36, and I have 0 roots, or 0 x-intercepts. And for the last one, with my a, b, and c value, I had negative 2 squared minus 4 times 1 times 1, which gave me an answer of 0. And I had 1 x-intercept. So from this, what do you think we have to look for in this specific part, in this discriminant, that will tell us whether or not, or how many, or not whether or not, well, I guess whether or not we have any x-intercepts, and then specifically how many we have. Well, in this case, if the discriminant is greater than 0, so what we mean by that is it a positive number. If our discriminant is a positive number, we have 2 zeros, or 2 roots, or 2 x-intercepts. All means the same thing. If the discriminant is less than 0 or negative, then we have we have 0 zeros. Because that goes back to the scenario where we can't square root a negative value. And if the discriminant equals 0 itself, we have 1 0 or 1 x-intercept. So all we have to look for, if we're only concerned about the number of x-intercepts, is we just have to look at this discriminant. If we want to know the specific values, then unfortunately we do have to go through and use the quadratic formula, or factor it, or graph it, whatever the case may be. But again, if we're only looking for the number of roots, we don't have to graph, or we don't have to go through and do the full formula. We just need the discriminant. So in this case, I want to determine how many roots I have. So I'm going to use the discriminant, which is the b squared minus 4ac. So negative 4 squared minus 4 times 1 times 3. So we get 16 minus 12, which gives me 4. This is a positive value, or a positive discriminant. So therefore, we have 2 roots. For B, same idea. Find your A, B, and C value as if you would be finding or going through and calculating or using the quadratic formula, except because we only want the number of roots, we're going to be using just the discriminant, just the part underneath the square root. So we have 2 squared minus 4 times negative 1 times negative 3. So 4 minus 12, which gives us negative 8. So because we have a negative value, if we were to square root that in our quadratic equation, we wouldn't be able to continue any further. We would have an error. So therefore, there are 0 roots, because again, we have that negative value for our discriminant. So again, the main thing from this lesson is just how to determine the number of roots that we will have, whether it's 0, 1, or 2. We looked at how to find it in the different scenarios or the different forms of the quadratic equation. However, with the standard form, rather than use the quadratic formula, what we can use is just specifically the discriminant, which is the part underneath the square root. And we had a summary of, depending on what that value was, or the value of the discriminant, that would give us the number of roots, or zeros, or x-intercepts. All different terms for the same thing. So again, just kind of a subset, or like kind of a small break off of the quadratic formula, depending on what the question's asking, or what the context is, or what we're looking for. If you're not comfortable with the quadratic formula, I do recommend you go back to the previous lesson just to make sure that you are comfortable with it.